Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 5, Section 2, Chapter 2, Topic 2.
Semiconductor package manufacturing involves a meticulous process that can be broadly categorized into three main phases: sort, assembly, and final test. Each phase plays a crucial role in ensuring the quality, functionality, and reliability of the packaged integrated circuits, ICs. In this overview, we will delve into each phase, exploring the key steps, technologies, and considerations involved. 1.
Sort phase. The sort phase marks the beginning of semiconductor package manufacturing, where the individual semiconductor dies are sorted, classified, and prepared for assembly.
1. This phase encompasses several critical steps aimed at identifying and organizing dies based on their electrical characteristics, performance specifications, and intended applications.
A. Wafer inspection. The process begins with wafer inspection, where the semiconductor wafers containing multiple dies are thoroughly examined for defects, impurities, or irregularities.
Advanced inspection techniques, such as optical inspection, scanning electron microscopy, SEM, and automated defect detection systems, are employed to identify potential issues that may affect die quality and performance. B. Die sorting. Once inspected, the semiconductor dies are sorted or classified based on predefined criteria, such as electrical parameters, functionality, and yield. Automated die sorting equipment, including pick-and-place machines and robotic handlers, are used to separate dies into different bins or trays according to their classification. C. Quality assurance. Quality assurance measures are implemented throughout the sort phase to ensure the accuracy, consistency, and reliability of the sorted dies. This includes validating electrical characteristics, verifying functional performance, and conducting statistical analysis to assess yield rates and defect levels. 1. Assembly phase. The assembly phase involves the physical assembly of sorted semiconductor dies onto carrier substrates, forming complete semiconductor packages. 1. This phase encompasses a series of intricate processes aimed at bonding, interconnecting, encapsulating, and protecting the semiconductor dies while facilitating electrical connections and thermal dissipation. A. Die attachment. The first step in the assembly phase is die attachment, where the sorted semiconductor dies are bonded or attached to carrier substrates using adhesive or soldering techniques. Precision and accuracy are crucial during this step to ensure proper alignment and contact between the die and the substrate.
B. Interconnect formation. Once attached, interconnects are formed to establish electrical connections between the die and the external leads or contacts on the package.
This may involve wire bonding, flip chip bonding, or other interconnection methods, depending on the packaging technology and design requirements.
C. Encapsulation. Following interconnect formation, the semiconductor package is encapsulated or sealed using materials such as epoxy resin or molding compound. Encapsulation provides mechanical support, environmental protection, and structural integrity to the packaged ICs, shielding them from moisture, dust, mechanical stress, and other external factors. D. Thermal management. Thermal management elements, such as heat sinks, thermal pads, and thermal vias, may be integrated into the package design to facilitate heat dissipation and regulate operating temperatures. These elements help prevent overheating and ensure optimal performance and reliability of the packaged ICs. 1. Final test phase. The final test phase is the last stage in semiconductor package manufacturing, where the assembled semiconductor packages undergo rigorous testing and inspection to verify their functionality, performance, and quality before shipment to customers. A. Functional testing. Functional testing involves subjecting the packaged ICs to a series of electrical stimuli and operating conditions to assess their ability to perform the intended functions accurately and reliably. This includes testing various functional features, interfaces, and operating modes to ensure compliance with product specifications. B. Quality control. Quality control measures are implemented during final testing to detect any defects, irregularities, or deviations from the expected performance parameters. This may include visual inspection, electrical testing, thermal testing, and reliability testing to assess the overall quality and reliability of the packaged ICs. C. Traceability and documentation. Throughout the final test phase, traceability and documentation play a crucial role in tracking the manufacturing history, test results, and quality assurance data associated with each semiconductor package. This information provides valuable insights into the manufacturing process, facilitates root cause analysis, and ensures compliance with regulatory requirements. In conclusion, the sort, assembly, and final test phases are integral components of semiconductor package manufacturing, each contributing to the production of high-quality, reliable, and functional integrated circuits. By meticulously executing these phases and leveraging advanced technologies and quality control measures, semiconductor manufacturers can meet the stringent demands of the modern electronics industry and deliver innovative solutions to customers worldwide. Thanks for watching. Please like, share, and subscribe.